Hi guys, we are now on the third part of our discussion about manometers. So right now we are going to start solving problems involving inclined manometers. So mag-start muna tayo sa basic discussions about manometers, saka tayo magsosolve ng medyo mas komplikadong questions. Okay, so kailangan lang muna maintindihan natin or we have to establish the basic principles in solving problems involving inclined manometers. Okay, so we will be solving these two questions that are coming from Fluid Mechanics, Fundamentals and Application by Cengel and Cimbala. So we took these questions from these books and we will try to solve it now. Okay, so let us begin with this problem. So you can find this in problem 3-149 sa ating reference book. When measuring small pressure differences with a manometer, often one arm of the manometer is inclined to improve the accuracy of the reading. So this is basically the reasons why we are using an inclined manometer, okay, for better accuracy ng ating mga reading. The pressure difference is still proportional to the vertical distance and not the actual length of the fluid along the tube. So on this problem, this is what we want to emphasize here. Okay, the pressure difference is proportional to the vertical distance. So this is what we want to highlight on this problem, that the pressure difference that we will be using is the vertical distance and not the actual length of the fluid. Okay, so for example, in this figure, as you can see, we have the actual length. So when we are solving an inclined manometer, ang concern natin is the pressure difference on the vertical, not on this length. Okay, so this will be our concern in calculating for the pressure. Okay, now let us try to solve this problem. The air pressure in the circular duct is to be measured using a manometer whose open arm is inclined 25 degrees from the horizontal. So as you can see, this is our open manometer and it is inclined 25 degrees from the horizontal. The density of the liquid in the manometer is 0.81 kilogram per liter. Okay, so the density of our liquid here, so let me write, okay, so that our figure here will be our overall reference. Okay, so the density of this is, okay, the density of our liquid is, where is it again? 0.81 kilogram per liter. Okay, and the vertical distance between the fluid level in two arms of the manometer is 8 centimeters. So this is what we have here. So converting that into meter, it is 0.08 meter. Okay, para hindi na tayo mahirapan mamaya mag-convert. Determine the gauge pressure of air in the duct and the length of the fluid column in the inclined arm above the fluid level in the vertical arm. So meron tayong hinahanap na dalawang items. So let us write our required here. So required. So first we need to find, okay, first we need to find the gauge pressure of air in the duct. So the gauge pressure of air in the duct. Okay, so we need to find that pressure in here. And then we need to find the length of the fluid column in the inclined arm above the fluid level in the vertical arm. Okay, so we need to find the value of L. Okay, so yan ang hinahanap sa atin dito. Alright, so let us start our solution. So first, what we are looking for is the gauge pressure. Okay, the gauge pressure of air in the duct. Okay, so we know that gauge pressure is equal to the absolute pressure minus the atmospheric pressure. Alright, so now if we're going to analyze this, we know that the pressure from here, so this will be actually the pressure of our air in the duct. So this will be our PA that we are looking for. So the pressure on this level, we know from our previous lesson that it is equal to the pressure on this level. So this is also equal to PA. right? So basically, we just need to solve the pressure coming from our open manometer. So basically, this what we have here as our gauge pressure. This is equal to rho GH. Right? So we learned this from our previous lessons about static fluids. Alright, so what we have here is the density of our liquid, which is 0.81. So 0.81 kilogram per liter times our G, which is 9.81 meter per second squared, and our height. So, katulad nung binanggit natin kanina, the pressure difference is still proportional to the vertical distance, not on the actual length. Ito yung actual length ng ating liquid, di ba? But we are not concerned on that when we are solving for our pressure in manometer. Our concern is the vertical height. So, our height will still be this one, not this L. Our height will be the vertical distance, okay? So, that means our H here is equal to 0.08 meters. Alright. So, tandaan natin, ang hinahanap natin is yung pressure sa ating duct. Okay? I'm sorry, this is absolute para hindi tayo malito, no? So, that means this is our PA. Okay? So, the pressure in our duct. So, the pressure in our duct. So, our answer should be in a unit pressure, right? So, it should be expressed in Pascal. So, we need to convert our units to Pascal. So, first we have liters here. We need to convert that to cubic meters. So, we have 1,000 liters per 1 cubic meters. And then, our kilogram meter per second squared, let us convert that into Newton. So, 1 kilogram meter per second squared is equal to 1 Newton. And then, 1 Newton per meter squared is equal to 1 Pascal. Okay, so let us check our unit. Dapat maging consistent yung ating mga units. So, we have kilogram. So, it will be cancelled here. Our liter will be cancelled here. Our second squared will be cancelled here. Then meters, we have square meter, we have cubic meter here. So we still have 1 meter, but it will be multiplied to this meter here. So we have meter squared, but we have meter squared here. So it will be cancelled out at the end, right? Then our Newton will be cancelled out. So our unit will be in Pascal. So if we calculate this, the final answer will have a unit of Pascal. Okay, so let us now try to solve for that. So let's bring out our calculator. So simulan natin sa 0.81 times 9.81 times 0.08. Then what's next? Times 1,000. Okay, so our answer here is 635.69 Pascal. And this is our final answer for our problem, but we still need to get the value of L. Okay, so to get the value of L, it will just be a simple trigonometry. So, as you can see, we have a similar triangle here. Our angle is 25. And this length from here up to here is 8 centimeters. So therefore, our right triangle here will be like this. So this is our right triangle. Okay, so this is our length L. And as you can see, we have an angle of 25 and our height is 8 centimeters. So we have angle of 25. And our height is 8 centimeter. Okay, so we'll just be using trigonometry to solve this problem. So we know that sine of 25 degree is equal to 8 centimeter over L. So therefore, our L is equal to 8 centimeter over sine 25. So 8 divided by sine 25, which is 18.93. So our answer here is 18.93 centimeter. And this is our final answer here. So nakuha na natin yung pressure, okay, the gauge pressure of the air in the duct and the length of the fluid column. So basically, hindi naman ganun kahirap tong problem na to, but we need to emphasize here that our concern is the vertical distance, hindi itong length, okay, ng ating actual length ng ating fluid here. Okay, so when we are calculating for the pressure, our concern is the vertical distance. Okay, so now let us have another problem. So this is found in problem 3-156. So the pressure of water flowing through a pipe is measured by the arrangement shown in figure 3-156. So this is the figure. For the values given, calculate the pressure in the pipe. So this is what we need to find out. The pressure of the water in the pipe. Okay. So first, let me label that as PW. Okay, para meron na agad tayong reference. So we have PO in here, as you can see, with air. And then we have a water. Then ito yung ating inclined manometer. And our liquid here is having a specific gravity of 2.4. Now, in here, the given vertical height or distance here is coming from this level up to the center of our pipe. So basically, from our PW, which is 8 centimeter. So we do not know what is the vertical distance coming from this point up to this point, or from this point up to our pipe. Okay, so let me name this as our P1, so we will not get confused. So this level is P1, so that means this is also P1, right? Because our pressure coming from here up to this point will be equal to our pressure from here up to this point. So that is what we are going to balance basically, right? So ginawa na natin to in our previous lesson, so this should not be new to us. So hindi na natin kailangang i-discuss why we are doing such. Okay, so to understand our length, let us label, okay, yung mga kailangan natin. So from here, dahil we know already that we need the vertical distance. So from here to here, let us say this is our H1. So we cannot use H2 because this is already H2. So from this up, from here up to here, this will be H3. Okay, so we could easily identify our values. Okay, so what else do we need to identify here? Okay, so now all of our units is in centimeter, but we know that during calculation we need to convert that to meter. So this is 0.5 meter, and here 6 centimeter is 0.06 meter, and 8 centimeter is 0.08 meter. Okay, we will be using that in our calculation. So let us start our calculation. Okay, so as we said, the pressure from this side up to P1 will be equal to the pressure of this one up to this point. Okay, so let us balance that. So let us start from here. So first we have our pressure PO. So let us write that here, PO. Then plus our pressure from this point of our water, from this point up to this point, which is having a height of 50 centimeters. So this is composed of water. Okay, our liquid here is water, so we will be using our density of water here. So density of water times G and times H. So our H is H2. Okay, so we already reached this point. Okay, so this will be equal to the pressure from here going to this point. Okay, so we know that we have a pressure here, which is PW. Yan ngayong ating required. So PW plus the pressure coming from PW up to this point. Okay, so let us say this is our P2. Okay, just to identify, para alam natin yung pinag-uusapan natin. So, this is P2. Right? So, we need to get our pressure from our pipe up to point P2. So, our liquid here is water. So, we have the density of water times our G times our H. So, tulad ng binanggit natin kanina, our concern is the vertical height, which is H1. Hindi itong length na to, okay? Our concern is H1. So, therefore, this will be H1. Okay? Next, we have from P2 going to P1. So, this will be plus density of, because our liquid now here is this gauge liquid, our gauge fluid, having specific gravity of 2.4. So, here, density of the fluid times G times H. So, what will be our H? The vertical distance from P2 up to P1. So, it will be this one. So, hindi itong L na to, okay? Our concern is the vertical distance, which is H3. So, this will be H3, okay? Now, how many unknowns we have here? We have the value of PO. We have the density of water. We have the G. We also know the value of H2. So, basically, lahat ng nasa left side ng ating equation are known values. For our right side, we have PW, which is unknown. Yan yung hinahanap natin. We know the density of water, the G. H1, we don't know because what is given is L2. And then, density of our fluid, we can get because we have the specific gravity. H, and then G, and then H3. We don't know also H3, but meron tayong given na L1. So, therefore, we can calculate for H1 and H3 using trigonometry, no? So, this is our inclined manometer. And then, let us identify our values in here. So, if this is our length of our inclined manometer from point P1, we will start from point P1 because we know the value from the center of our pipe down to our H1. So, let us write that one para mas maging madali yung ating calculation. So, from here to here. Okay, so this will be our height, which is 8 centimeters. So, let me write that. Our height is 8 centimeter. Okay? Now, for our inclined manometer, which will be the hypotenuse of our triangle, so let us identify our point. So, this point, which is the bottom of H1, okay, this is P1, right? So, this will be our P1. Now, at the end of our manometer inclined, we have PW at the end. So, this will be the area for PW. And then, somewhere here is our P2. Okay, from P1 going to P2. So, this will be P2. Okay, so, may mga given points na tayo. Now, we don't know the angle. We are just given with angle theta. So, this will be angle theta. But, we know the length from P1 to P2. Okay, we know the inclined length. So, this one is known, which is L1. So, L1 is equal to 6 centimeter. And also, from this point, which is P2, going to PW, is also given L2, which is 6 centimeter also. So, L2 is equal to 6 centimeter. So, as you can see, we have similar triangle here. So, dahil pareho silang 6 centimeter, so we can calculate for the value of our angle here. So, we can calculate for the value of our angle here. So, we know that sine theta, the sine of our angle is opposite over the hypotenuse. So, if this is 6 centimeter and this is 6 centimeter, so therefore the total is 12 centimeter. So, sine is opposite over hypotenuse, so we have 8 centimeter over 12 centimeter. So, therefore, our sine theta is equal to, so sine theta is 8 divided by 12, which is 0.6667. right? So this is our sine theta. Now, if we move this from point P2 going here, okay, so let me extend that here, and from our PW and from this, we know already that we already have label here. So from here to here, this is our H1 and this is our H3. So we can calculate for their value because we know the hypotenuse, right? So dahil parehong kanilang hypotenuse, which is 6 cm, and pareho rin yung angle, that means equal yung value ng H1 and H3, di ba? So we can calculate for that. So we have sine theta, which is sine theta, which is 0.6667, is equal to opposite over hypotenuse. So H1 over 6 cm. Okay, so that means our H1 is equal to 6 times 6.667. So our H1 is equal to 4. So we have 4 centimeters in here. Now, our H3 is the same because sine theta for H3 will also be H3 over 6 centimeter. So therefore, our H3 will also be equal to 4 centimeter. Okay, dahil pareho yung kanilang hypotenuse na 6 at pareho yung kanilang angle. So we know the value of H1 and H3 now. So that means we can now substitute that here sa ating equation dito. So PO, we know the PO, right? PO is given at 30 kilopascal. So we have 30 kilopascal plus the density of water, which is 1000 kilogram per cubic meter, times our G, which is 9.81 meter per second squared, and then our H2. Our H2 is 0.5. Okay, it's given here, 0.5 meters. And this is equal to our PW, yan ang ating hinahanap, plus the density of water. Now we're going from this direction. Okay, so dito na sa right side. So the density of water is 1000 kilogram per cubic meter times G, which is 9.81 meter per second squared, times H1. So alam na natin yung H1. Our H1 is 4 centimeter, but we need that in meters. So let me convert that. So we have 0.04 meters. Okay, this is also 0.04 meter. Okay, so our H1 is 0.04 meters plus the density of our fluid. So we have the specific gravity, which is 2.4. So 2.4 times the density of water, kilogram per cubic meter, times 9.81, which is the D, meter per second squared, times our H3. Our H3 is 0.04 meter. Alright, so we can now calculate for our values para mas madali, no? Solve na natin per term. So we have here 30 kilopascal plus, unahin na natin yan. Okay, so I will show you by calculating per term para mas maging malinaw. Kasi pag kinalculate ko ng diretso, baka hindi maintindihan kaagad, no? Malito kayo dahil sa dami ng numbers and units. So let me do it per term. So we have 1000 times 9.81 times 0.5. So 4,905. So what is our unit here? So as you can see, our unit here is in kilogram meter second squared, meter and cubic meters, no? So I will not cancel this meter in here, okay, because we need to solve, or we need to get our answer in Pascal. So I need the Newton value. So I will just get this meter here. Okay, so this will be cancelled out, this meter, and we will have square meter in here. Okay, so the same goes in other terms that we have here. So this will be cancelled out, this will be meter squared, this will be cancelled out, and this will be meter squared. So yan lang muna ang ating isosolve. So we have kilogram, okay, meter per square meter second squared. Okay, so i-convert na natin siya sa Newton. Okay, so iniisa-isa ko para mas madali ninyong maintindihan yung ginagawa ko, no? Kasi baka malito tayo eh. So we have 1 Newton is 1 kilogram meter per second squared, and we need to convert that to Pascal. So 1 Newton per square meter is equal to 1 Pascal. Then 1 Pascal or 1000 Pascal is equal to 1 kilopascal. Okay? So ito yan, ito pa lang yan, no? Nag-convert lang tayo. So this is equal to PW plus, we have 1000 times 9.81. So let's calculate for that. 1000 times 9.81 times 0.04, which is 392.4. Then our unit is kilogram meter per meter squared second squared. So ganun din, kung convert din natin, ano. So 1 kilogram meter per second squared is equal to 1 Newton. Then 1 Newton per square meter is equal to 1 Pascal. Then 1000 Pascal for 1 kilopascal. Okay, so ito pa lang yon. Now we're going to have this. So this is still plus. So part pa rin to ng ating equation sa right side, no? So we have, let us calculate for that. We have 2.4 times 1000 times 9.81 times 0.04, which is 941.76. So our unit is the same, kilogram meter per square meter per second squared times 1 Newton per 1 kilogram meter per second squared. Then 1 Newton is per meter squared is equal to 1 Pascal. Then 1000 Pascal per 1 kilopascal. Right, so isang buong equation to, ha, kasunod pa rin ng right side natin itong nasa ibaba. So let us be clear with our unit. Our kilogram will be cancelled out, our second squared will be cancelled out. So we have square meter in here. Newton muna, Newton will be cancelled. Our square meter will be cancelled, and our meter will be cancelled. So as you can see, our Pascal will be cancelled. So our unit will be in kilopascal. So the same goes here. So makakancel lang lahat ng to. So our unit is in kilopascal. Okay? So pare-pareho lang yan. Dahil pareho lang yung naging conversion natin. So as you can see, masyadong mahaba lang conversion kasi whenever I'm solving, I think it is easier to explain if the students are seeing yung mga units natin, ano. Kaya hindi ko siya sinu-shortcut kasi kung pag sinortcut ko, hindi maiintindihan. So mas maganda kahit mahaba, ipakita natin kung paano natin siya sinusolve, no? So we have here 30 kilopascal. So 30 kilopascal plus, so what do we have here? 4,905 divided by 1,000. So we have 4.9 kilopascal is equal to PW plus here 392.4 divided by 1000, so 0.3924 kilopascal, then plus 941.76 divided by 1000, so 0.941.76 kilopascal. So therefore, we can now isolate our PW. So our PW is equal to 30 kilopascal plus 4.905 kilopascal minus 0.3924 kilopascal minus 941.76, sorry, 76. So let us remove this. Okay, naging dalawa yung ating decimal point. Okay, kilopascal. Okay, so now we can calculate for the value of PW. So we have 30 plus 4.905. Then we will subtract itong dalawa. Minus 0.3924 minus 0.94176. So we have 33.57. No? So we have 33.57 kilopascal. And this is our final answer here. Okay? So, ito yung pinahanap sa atin. What is the pressure in our pipe? So, basically, this is what we are going to do when we are having a problem involving inclined manometer. So, ang pinakamahalaga lang naman na maintindihan natin is our concern is the vertical height or the vertical distance. Hindi itong distance na actual ng fluid natin. No? Hindi yan ang kailangan natin. So, if you use the actual distance here, you will not be able to calculate the proper height for our formula rho GH, diba? So, that will be our procedure to follow when we are solving problem for manometer. So, on the next video natin, we are going to solve inclined manometer in which our values will vary. Katulad nung ginawa natin sa previous problem natin, if you remember, meron tayong funnel, the reading of our manometer is changing. So, we will be doing the same, but this time our manometer is inclined. So, with all of that and more, I will see you in our next video. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa engineers.org.